welcome to our program, Astronomy for Everyone. Our topic this month is Mars, and here to talk with us about the red planet is Dr. Dale Parton, Professor of Astronomy at Macomb Community College and a member of the Warren Astronomical Society. Dale, welcome to the show.
Thank you.
Now, there's a lot of fact and fantasy about Mars, and it's making its closest approach to Earth on October 6th. And no, it won't look as big as the full moon. So please give us some reliable information.
Okay, Mars and Earth will pass close to each other, their closest approach, as you say, on October the 6th, at which point Mars will be a very bright red star-like thing in the southern sky. Right now, you can see Mars quite easily. I was out a couple nights ago. Look to the east after it gets dark. It's a bright reddish looking star-like thing.
Okay, we'll have to head outside. Hopefully it will stay clear. So let's talk about the planet, how it looked 4 billion years ago and what it looks like today.
Well, yeah, it's really changed a lot. And the question is, what happened to Mars? We've learned from lots of studies of Mars, from rovers and spacecraft orbiting it, that Mars used to have an ocean in its northern hemisphere and rivers flowing, rain, thick atmosphere, pretty warm place. Pretty similar to Earth now. But over the last 4 billion years, things have changed. If you look at the next, it's become a desert, a cold desert. If you look at the next picture, you can kind of see the reasons for this. There's two basic reasons. One is Mars is smaller than the Earth, and the other is Mars is farther from the sun than the Earth is, so it gets less warmth from the sun. Both these planets were very hot shortly after the solar system formed. Mars, being smaller, cooled off faster, became a very cold place. Mars, also being smaller, had less gravity, only 38% of Earth's gravity, so it couldn't hold down its atmosphere very well, and lost most of it. And once the atmosphere was gone, the ocean and the rivers boiled away under low pressure. So most of the water was lost to space, but some of it soaked in underground and it's still there.
Well, how were scientists able to figure out just what Mars may have looked like 4 billion years ago?
Well, partly that's from doing lots of studies of Mars from orbit around Mars. We can measure the elevations and see that there was a depression in the northern hemisphere. We can see dry riverbeds that obviously used to have water flowing through them. We also have ground penetrating radar that can see underground water in different areas of Mars. So that's some of the things we've done, plus rovers that sample the Martian surface that tell us what Mars was once like.
Well, you mentioned with the ground penetrating radar, there's water underground. Would we be able to get to this water supply?
We certainly would. It varies how much is there and how deep it is with location, but in many areas, it's not very deep. It's a few feet deep, or maybe 30, 40, 50 feet deep in other areas, but it's not deep. I think earlier on, we didn't know that there was a lot of water, which is likely frozen underground. At this stage, the things we would most like to know have to do with, is there life on Mars, which would be primitive life.
Primitive like bacteria?
Yes. People once thought there were intelligent aliens living on Mars. It's now pretty clear that's not the case and never was. But there could be bacterial life, or maybe there once was such life on Mars. Other
Has
interesting
Curiosity
questions.
been able to find any evidence of that?
Well, what the Curiosity rover has done is it accomplished its prime mission. That was to answer the question, was Mars ever a suitable place for life? And the answer that came back from the Curiosity rover very clearly is yes. Billions of years ago, Mars had a warm, wet climate. The water on Mars was not too acidic or too basic, and there were the right kind of minerals with chemicals like calcium and phosphorus and oxygen and carbon and so forth that would be needed for life. But the Curiosity rover does not have the right equipment to look for organic compounds that would tell us that there, in fact, was or is life. The new rover that's on its way to Mars now, the Perseverance rover, has that equipment. So we might get answers after it gets there.
And that'll be in February, I believe?
Yes, should land in February. And, we could see an answer within half a year if things go well.
Looking forward to that. Now, there are some issues associated with people going to Mars. One of them would be weightlessness.
That's correct. If you look at this picture, on the left, you see people floating in space. They're on an aircraft that went up high, turned off its engines, and is just slowly coasting back down into the atmosphere. So they experience weightlessness for a few minutes. That's fun. But when you're on the International Space Station and you're weightless for half a year, it's not so fun. Your muscles atrophy because they don't have gravity to deal with. Your bones lose density and other problems. And so being weightless for long periods of time, such as would be required to coast to Mars, is a problem that has to be fixed.
Do you have any ways of dealing with that?
Yes, if you look at this picture, the basic way that it could be dealt with is using centrifugal force to create artificial gravity. Here you see two spacecraft tied together with a tether and slowly orbiting each other. This would create artificial gravity, and you would feel like you were on Earth. So that is fixable.
Now, in addition to the issues with weightlessness, as you just mentioned, artificial gravity or exercise, there's also the issue of radiation exposure, correct?
That is absolutely correct. There are two sources of radiation in space. There's solar wind from the sun, which is mostly protons, that needs to be shielded against, especially during a solar storm. Those are relatively low energy particles, so they can be shielded fairly easily. The more serious concern is cosmic rays coming from distant galaxies. Those are much higher energy. And if not appropriately shielded to at least reduce them enough, they could cause serious health problems down the road. So we need shielding going to Mars. And once we get to Mars, most of the time, people will have to stay underground for protection from cosmic rays.
Well, you mentioned when we get to Mars. How are we going to get there?
Well, companies like SpaceX are currently working on building large reusable space vehicles, reusable to get the costs down so we don't need a new vehicle every time we send people there. And also the new thing is to not have to carry all of the fuel and oxidizer like oxygen all the way to Mars and then use it to fly back. The new way of doing this is we will generate methane fuel and also oxygen from Martian materials to power the rockets that will bring people home. So that's being actively pursued right now. In fact, the Perseverance rover has some experiments on it to explore that chemistry of generating fuel on Mars. Also, if you look at the next picture, you can't go to Mars anytime you feel like it. You have to wait until the Earth and Mars are at the right part of their orbit where they're coming close to each other to get to Mars without needing too much fuel. And the two planets only line up that way every 26 months, or a little over 2 years. So we just had that launch window, and there's 3 spacecraft going to Mars right now from NASA, from China, and from India.
So we have those countries sending probes out and to study the environment. But I understand the Martian environment is basically lethal. I mean, how do we overcome the problems with those conditions present?
You're absolutely right. If you just stepped out of a spacecraft wearing ordinary clothing, no spacesuit, you'd be dead almost instantly. The atmosphere is thin and unbreathable. So you need to be in a spacesuit if you're outside or indoors in a pressurized environment. The temperature is, especially at night, is super cold on Mars. Well, we know how to heat houses. We can heat a habitat on Mars. There's low gravity on Mars. It's only 38% of Earth gravity. To the extent that that's not enough to keep us healthy, the brute force approach to fixing that is with a centrifuge that you could live in part of the time. You're going to need shelter from cosmic rays because the atmosphere is not thick enough to shelter you like ours is, fortunately. So that would mean being underground a lot. There's no water on the surface, but it's not too far underground, so we can get it. You can't walk outside and pick an orange off a tree. We'll have underground farming, and the soil has some toxic materials in it. Chemists have been studying that, and it's pretty easy to get those materials out of the soil so you can grow food in it. Just basically rinse the soil in water. So we know how to deal with those kind of problems, not that they're not challenges.
It sounds like
showstoppers.
It sounds like it would be quite challenging, but I imagine we're up to the challenge. Now, right now, we're going to take a quick break, and if you have a question, please send us an email. The address is down at the bottom of the screen. And coming up next with Term of the Month is Stephen.
The term of the month is Falcon Heavy. The SpaceX Falcon Heavy launcher has the highest payload capacity of any current rocket at 140,000 pounds to low Earth orbit. It is not expected to deliver humans to Mars. The Saturn V delivered 310,000 pounds to low Earth orbit for an Apollo moon landing mission. 11,000 pounds was landed on the moon. That landed 2 people to get samples, do experiments, and launch back into lunar orbit to meet their ride home. How about Mars? The Curiosity spacecraft was 8,600 pounds at Mars orbit. 77% of this was used to get the rover to the ground. The lunar lander would have to be 47,000 pounds in Mars orbit. That's 10,000 pounds more than a Falcon Heavy can get there. And it wouldn't be enough to return to Mars orbit because Mars orbital speed is 23 times higher than the moon's. Perhaps Mars launch fuel could be placed there beforehand, landed or created there with robotic precursor missions, and yet the Falcon Heavy puts 13 times as much mass into low Earth orbit as the Saturn V per dollar spent, being mostly reusable. That's the kind of thing that we'll need to get to Mars. It would take a lot of missions. Term of the month, Falcon Heavy. Back to you, Don.
Thanks, Steve. We're here with Dr. Dale Parton from Macomb Community College, a professor of astronomy there, and we're discussing Mars. So, Dale, we talked earlier about the soil and growing things, and the soil being lethal. We could fix it, but still, how would we feed ourselves on Mars realistically?
Well, one of the issues that we'd have to deal with first is how do we get electrical power? And
This is true. We have to power however we're going to farm, probably
yeah,
hydroponically.
that's right. So an issue with getting electricity is we'd likely like to use solar cells, and we get big dust storms on Mars that block out the sky for weeks or months. So we would need backup power, either little nuclear reactors that NASA is developing, or we'll be generating methane and oxygen for rocket fuel. We can just burn some of the methane in a generator to make electricity. This would enable us to power underground farms. We'd be underground for protection from cosmic rays. It would be pressurized, so we don't need spacesuits. So we'd have underground farms to grow food. That's how we'll do it.
Yeah, that would seem to be the way to go. And like you say, using solar arrays with the dust storms, we could be out of luck for weeks or months. Now, we talked earlier about the problem of gravity or the lack of it. How do humans adapt to that lower gravity?
Well, I don't think we want to rely on natural evolution, because that would take many generations, maybe 100 at a guess.
So we're humans out of the picture here, right?
Yeah, we'd need to do artificial evolution by genetically re-engineering ourselves so that we're optimized not for 1G of gravity like we have on Earth, but for 38% of this gravity, so we'd be optimized for Mars. That's for people who will be staying on Mars for the rest of their lives, because once you do that, you wouldn't be able to come back. You'd just feel you'd be totally unable to function in 1G of gravity anymore.
So we'd be essentially creating a different human species of sorts.
Yeah, Homo Martian.
There might be certain ethical questions there. I don't know. But yeah, it's something to ponder, that's for sure.
I think if we look a little farther down the road, though, what are human settlements going to look like? In the medium term, by which I mean a few centuries, I think we're going to build whole cities underground for protection from cosmic rays. They will be warm and pressurized, have air to breathe. We'll have an artificial sun travel across the sky each day, and rain falling from pipes. It won't look curved the way you see in this drawing. It'll look flat. So I think that's what we're going to see medium term. Long term, it's going to look different.
How so?
Long term has to do with, can we terraform not an underground part of Mars, but the surface of Mars? Now we're talking about a whole planet. This is going to be a major challenge. The first thing to do is to make the atmosphere thicker. One way to do that, and now we're talking about on 1,000-year time scale, is to steer comets in to hit Mars. We know how to do it in principle. We'll make sure they hit in areas where there's no human settlement. and they will deliver large amounts of water and atmospheric gases. Once the air on Mars starts getting denser, it'll start trapping more sunlight. We want global warming on Mars. And so that'll help warm the place up. And also, a thicker atmosphere will give protection from cosmic rays. So that's the long-term view of Mars. So I would have to tell you, I think we'll be going to Mars late this decade or early in the 2030s. The first people will go will be risk takers. But after another 10 years or so, when we got things working well, it'll be a great place to go for those who like to be safe. I hope I get a chance to go.
Me too. I just think that would be great, but well, maybe that's for a younger generation.
Maybe so.
Yeah. Well, Dale, I want to thank you, very much for coming on the show to talk to us about Mars as it makes its grandest approach to Earth. You can check out our club website. The address is down at the bottom of your screen as always. I want to let you know about the annual Astronomy at the Beach event, which this year will be virtual. It'll occur on Friday, September 25th and Saturday, September 26th from 6 p.m. until midnight. And again, this will be an online event this year. There'll be numerous live presentations, several remote telescope viewing sessions, and recorded presentations by local astronomers and some videos as well. Now, the special guests include Brother Guy Consolmagno, S.J., who is director of the Vatican Observatory in Arizona and a native Detroiter. Dan Davis, professor of geophysics at Stony Brook University in Stony Brook, New York. David H. Tweedy, the discoverer of 22 comets and the co-discoverer of comet Shoemaker-Levy 9. And Dolores Hill, a meteorite specialist at the University of Arizona, I should say, and a public outreach specialist with NASA's OSIRIS-REx mission to the asteroid Bennu. So again, keep in mind, later this month, the 25th and 26th, the virtual Astronomy at the Beach. And coming up next with What's Up in the Night Sky, here's Stephen.
Thanks, Don. What's up in the night sky for September 2020? Over the course of September, the sun rises from 7 a.m. to 7:30 here in Michigan and sets from 8 p.m. to 7:15. The days are getting shorter as we head to the winter solstice. September starts with a full moon on September 2nd. On the 10th, we have the third quarter. On the 17th, we have a new moon. And first quarter happens on the 23rd of September. Mercury goes from Leo to Virgo over the course of the month and sets from a half hour to 45 minutes after sunset. It is best at the end of the month. It is shown here, though, on the 18th of September because that's when the greatest western elongation happens. It's the farthest from the sun. If you're going to see Mercury, which I recommend, it's in the evening. Wait for the sun to actually go down before hunting for Mercury with your optics. You don't want to see the sun with your optics by accident or otherwise without proper, solar filter and so on. And that won't help you for looking for Mercury. Now, Venus goes from Gemini to Leo over the month. Now, it rises about an hour or so before sunrise, and here it is shown on the 1st, about an hour before sunrise. Uranus, Mars, and Neptune are shown here also about an hour before sunrise, but pointing in a different direction. Uranus is in Aries and rises in the evening. They all rise in the evening. It's magnitude 5.7, which makes it a pretty good target for seeing with just your naked eyes. You'll need a decent sky chart. I recommend having binoculars to help you find it, at least. It is a good time because opposition for Uranus comes up pretty soon, October 31st. Now, Mars is in Pisces and rises also in the evening. Earth is chasing Mars and catches up for an opposition on October 13th. Now, Aquarius is up all night because opposition is September 11th. It is magnitude 7.8. You'll need at least binoculars to see it. It is a good find because it's an unusual color. You'll need a decent sky chart, and I recommend, a little later in the evening, away from sunset at least. Now, Saturn, Pluto, and Jupiter are all in Sagittarius. They all set in the early morning, but it is shown here at 9 p.m. on the 1st. Pluto is a little weird because it, rather than being naked eye bright, it is magnitude 14.3. You'll need at least a 10-inch telescope to see Pluto. It is not a bad time to see Pluto, as Pluto is so far out. You will need an excellent sky chart down to magnitude 14, and you will need, as I said, at least a 10-inch or larger telescope, or possibly astrophotography. And that is what's up in the night sky for September 2020. Remember, we don't charge for this show, but we may tax your brain.